For mn are natural number, define a function f which is dependent on m and n, also x. Then function structure of defining is this: at x equal to 0, f mn is differentiable for each pair of mn with this condition where m is greater than n, differentiable for each mn with condition m less than n, not differentiable for each pair of mn with this condition, not differentiable for each pair mn with m less than n. We studied for options and we find that options are about differentiability or not differentiability. A function said to be differentiable if its right hand derivative or left hand derivative exist and equal. So we will check its right hand derivative and left hand derivative at a point 0, and if we find any condition on m and n, then we can easily tell about which option will be correct. Keep remember when we deal directional derivative. So directional derivative, if we find for this function, then it will give you sometimes quick review about the options discard. But here that will not be much helpful to find or discard options. Also, if directional derivative of a function exists at a point, then it doesn't mean that function is continuous at that point, because of we know that if function is differentiable, then function is continuous. So you will come across many situations whenever all directional derivative exist at a point but function is not continuous at that point. So we try to solve this problem, and we are going to find its right hand derivative limit and left hand derivative. So first, r f prime 0 means right hand derivative, that will be equal to limit h tends to 0 f0 plus h minus f0 divided by h, and this is same limit h tends to 0 fh minus f0 divided by h, and this will be equal to limit h tends to 0 h raised to the power m divided by h, and sine 1 upon h raised to the power n. This is h also, so you can write this will be equal to limit h tends to 0 h raised to the power m minus 1, as we use the law of exponent, sine 1 upon h raised to the power n. Keep remember what is n and h here, because of sometimes it look like same when we are studying online, because of way of writing for teachers or any teachers maybe differ, or sometimes they write h and n similar. So keep remember this point. So this is r f dash 0 means right hand derivative limit. Now find left hand at 0. So this will be equal to limit h tends to 0 f of minus h minus, or you can write 0 minus h, f0 divided by minus h, and this one can be written as limit h tends to 0. By the defining structure of f, we can write minus h raised to the power m divided by minus h, this is minus h, and into sine 1 upon minus h raised to the power n. Now this is same base, minus h and minus h, and exponent is 1, same base and in division, so exponent will subtract. So this limit can be written as limit h tends to 0 minus h raised to the power m minus 1 sine 1 upon minus h raised to the power n. And this one can be written as limit h tends to 0 minus h raised to the power m minus 1 sine 1 upon minus 1 raised to the power n and h raised to the power n. I took minus 1 as a common or separate from h, so it will help you to make condition over nh, because minus is appearing here also in this, so you can take outside. So it can be written as a limit h tends to 0. So if you took minus 1 from here, so minus 1 raised to the power m minus 1, this is from h, this part, and minus 1 raised to the power n is from also here. So you can subtract it minus n also, and this h can be written as h raised to the power m minus 1 and sine 1 upon h raised to the power n. So expression we obtained from left hand derivative is this one, and earlier we obtained the expression for right hand derivative. If function is differentiable, if we consider function is differentiable, then we can easily find the condition over m and n. So if f is differentiable at 0, then right hand derivative is equal to right hand derivative limit will equal to left hand derivative limit, and this is equal to limit h tends to 0 h raised to the power m minus 1 sine 1 upon h raised to the power n, and this is equal to limit h tends to 0 minus 1 raised to the power m minus n minus 1 h raised to the power m minus 1 sine 1 upon h raised to the power n. Now keep remember, if n is not here or m is not here, so we can find easily limit of right hand derivative, because sine function, we know that this is oscillatory function, so its value will be of finite, and also when h tending to 0, this limit will go to 0. So 0 into finite value, right hand derivative limit will be 0. But as m and n appearing here, if this is less than minus 1, if exponent of this h is minus less than 0, then limit may be infinite. So we cannot put a limit of a particular value as a limit. We put expression as we obtain from right hand derivative limit and left hand derivative limit. So you can see, I write clearly so you can see easily, sine 1 upon h raised to the power n, this one equal to, this expression is free from h, so you can take outside. So minus 1 raised to the power m minus n minus 1, and this is a limit h tends to 0 h raised to the power m minus 1 sine 1 upon h raised to the power n. So you can see this is the limit, and suppose this is L, and same this is also L. So you can say from both sides it is cancelled. So we obtain from 1 equal to minus 1 raised to the power m minus n minus 1, and this one can be written as minus 1 raised to the power 0. Now base is same, so we can compare powers or exponent of this. So 0 equal to m minus n minus 1, and this implies that m minus n equal to 1, and this implies that m is greater than n, because we are obtaining positive value when we differentiate m and n in this respective way. So m is greater than m. So condition we obtained over m and n, So function will be differentiable when m is greater than n. So option A will be correct and other options will be discarded here.